Hi, it's a pleasure. We are Team 4 and we are going to present the final challenge of this great continuous and by-agent simulation class. To achieve this challenge, it was decided to analyze and simulate the subway process found within the deck. Simulation methodology involved collating data on various parameters, including the arrival and delivery times of request products and the current workforce count. Subsequently, a goodness of fit test was conducted to ensure data accuracy. Following this, the data was input into Simulink for the simulations, and finally, experimentation was conducted to analyze the results. Previously mentioned, data collection stands out as a crucial aspect. Within this context, Subway adheres to the following process.
Some limitations and considerations of our simulation is that we focused only on the rush hour, which means that our results do not represent the whole labor day. Also, as in real life, operators do not have assigned roles. Because of that, we reduce the system into three main activities, which is the customer arrival, the order preparation, and the cashier's payment. We also collected data regardless of the type of product. We know that Subway produces different types of products, but that could also create dispersed data. So for the collection of data, we arrived one day at 11:50 a.m. until 2 p.m. and we recorded data of arrival rate of customers, order preparation time, and the cashier's process time. We got a total of 39 observations that we could use later for our simulation.
To be able to simulate the behavior of the source and the two processes, we perform a goodness fit test in Ex4Fit accredited three datasets. In the case of arrivals, we got a gamma distribution, a log Laplace for the sandwich preparation, and an invert wheelpool for cashier with the presented values. Since these models are from a sample, they only describe the behavior for the hour of compilation. The first step in creating a simulation is to select the units, in our case minutes, and set the time at which the simulation starts. As a second step, we place all the model resources, the source, the two processes, for the sandwich preparation and for the cashier, the queues between processes, and finally a sink to indicate the output or destroy the items.
Now that we have placed all the elements of the simulation, the processes, the queues, the source, and the sink, we have to connect them using the A connector, just like following the natural order of the customers and the orders going through the system. And also, we have to input all the data distributions we calculated in XPerfit for each of the processes. Now that we have placed all the elements in order to know how the system is performing in terms of utilization and state of the processes, the waiting time and content of the queues, we can add a dashboard where we can visualize all this information in graphs and tables. Finally, each team member carried out their own experiments, drew conclusions, and presented their own proposals for improving the system based on the results, answering the question, what's the best configuration, considering scenarios where the demand changed. This was the last part of the project. Thank you so much.